Good evening, ladies and gentlemen. Welcome to Lyft. My name is Mark Adams. I'm a principal engineer on the Lyft security team. I focus on detection and threat hunting. We're going to talk about DNS spoofing and an open source project that I've got. We're not really particularly talking about Lyft business this evening. I've been in security for 25 plus years. I've mainly been doing threat hunting and big data analytics. My fun fact is that I had to bribe a border official to escape a war zone. Is that not fun enough for you? Tough crowd. It's a long story, one for afterwards. There's some beer at the back, we can cover that one later. So we're talking about DNS spoofing this evening. I guess most of you know what the DNS system is. It's the system which holds the internet names together. So if you give DNS a name like example.org, you want to access a site called that, it goes and translates that into an address, and the IP addresses are what get put into packets that are delivered all around the internet. So if you've used host command line, that's the DNS client, essentially goes out to the DNS system, translates that into an address. If I've scared a bunch of you by going into command line stuff on slide 2, there's a cat picture for you. See, it makes it all better, right? So this is your typical DNS architecture. The client sits on the edge of the network, so like my Android phone, if I look up example.org, I go out through my ISP, there's an internet service there, typically bundles in some sort of DNS server, which is going to take that example.org. So my Android says, can you tell me the address for example.org? And that server says, I don't know actually, I'll go and ask the rest of the internet. And so a hierarchical distributed system starts off by looking up what .org is. Does anybody know about the .org domain? And then example.org. And then the reply comes back to my phone, hey, this is what the address is. So if we're talking about spoofing DNS, one thing I might want to do is put some sort of spoof platform on the edge of the network fairly close to my Android. That's monitoring all of the DNS requests coming out of the Android device. And when it sees something it wants to spoof, what it does is send a fake response back with a different address to what example.org looks like. Now, while all that's happening, all the stuff that I showed you on the previous slide is still happening. So the internet is still looking up example.org, the reply comes back, but it's too late. It's too late. It's lost the race with my spoof platform, which has given this fake address to redirect my Android to the wrong site perhaps. So the two important things that the spoofer needs to be able to do in this scenario, the first thing, it has to be able to spoof the source address and all of the metadata parameters of that DNS request so that it looks like it has come back from the real DNS server. And the second thing it has to do is win the race with the real response. So that response has got to arrive at the client before the real one does. I guess it's useful to talk about DNS spoofing in the context of a red team who wants to try and emulate what a real attacker would do on the network. So here's your typical red team approach. The DNS spoofing isn't an attack in its own right. It's part of an attack scenario where we're trying to take control of something that the client wants to be talking to and make sure that they're talking to the wrong service. So the red team would have to set up some sort of red team owned service, so say a web server that's going to pretend to be the real service. And then we would set up a spoofing operation to make sure that the response, we say we're going to coinbase.com, actually it gets redirected to the red team owned service. That's where the whole profit thing comes from in the title, by the way. And there is a lot of security in place, or should be. We'll talk about that in a second. But if good security is in place, the red team objective will be hard to achieve. And so the purpose of this red team objective is to test the security. And also here's a picture of my cat, and it's doing a KDOS attack. So I guess the current protections, let's talk about what protects DNS and prevents spoofing from being successful. There's a whole set of internet standards called Dns Sec, which is basically about signing DNS records so that the client should be able to detect when phony records have turned up. It's worth saying Dns Sec is extremely patchy on the real internet. There's whole bunches of hierarchy where there's no Dns Sec support. And then there's other application layer approaches. HSTS means that the browser will remember when an upgrade to more secure protocols hasn't taken place, and then we'll get concerned if that security isn't used in subsequent connections. And then TLS and certificate pinning and all the great things that you can find out on the OWASP website are used. So if the red team is trying to put phony certificates across, this kind of security should be there to protect the client. So how do we actually go about defeating some of those security controls? Well, here's the thing. DNSSEC is, because it's patchy, generally clients can't insist on it being present because otherwise everything would fall apart. And so one of the things, DNSSEC, all the digital signatures and everything like that is all delivered through DNS itself. So while we're in there spoofing stuff, we might as well spoof some other records that says that DNSSEC isn't working. And so that's what we can use to defeat DNS security. There's other techniques that I think red teams will be using all the time, like trying to get self-signed certs across to users. So I guess there can be behavioral approaches to try and get the users to click through and switch off security controls. And then certificate pinning and HSTS work on the second and subsequent attempts to contact a site. So if we can get in there and present different security parameters, then we can make sure that we beat those technologies. So let's now switch. I'm going to introduce you to an open source project that I've been working on and off for, it's over 10 years. Now, at the time I started this, I was working for an open source unfriendly organization. And so I never really got round to advertising it or associating it with my real persona in real life. So let's call this the Cyberprobe launch party. It's a toolkit. It's a toolkit for deep packet inspection. We use it for cloud scale stuff. I used it as part of a startup I co-founded 3 years ago. Where we did a lot of machine learning, big data analytics on network data. The Cyberprobe project essentially gets packets off of the network. We can collect everything or select based on some criteria such as IP addresses, sub-network ranges. We can arrange for a snort trigger to trigger collection of data, or a PCAP filter. There's some stateful analysis and a component which converts the packets into a very high-level set of network events, and then those network events are fed to user-provided Lua code where you can do whatever you like, basically. So I've used this to inspect events. It can output JSON, it can output protobuf, send events across gRPC to a service. I've also got integrations with the Gaffer's graph database. It's a large-scale graph database. We can use that to build network maps. Elasticsearch is a great place to store events for forensic analysis. Deliver stuff into a RabbitMQ using MQP. That's a good way to make sure that the events go into some back-end systems, and that's how I've done things like DNS tunnel detection by building analytics which take the events and start to build models across them. And we've got integration with Stix and Taxi for IOC. And the final set of features on Cyberprobe is that it's got 3 scenarios for packet injection. So the first thing is DNS spoofing. That's spoofing a response to a DNS request. It can also inject the TCP reset on a session that we want to tear down, and also inject a payload into a TCP session. But the DNS spoofing one is actually much more fun. Just to give you a flavour, we're not going to go through this in line-by-line detail, but this is what an example Cyberprobe configuration looks like if I want to do DNS spoofing. It's 20 lines of Lua. It's not a lot of work to put this together. This particular example says if we see DNS request, for example, .org, then we're going to send back a response, spoof a response that says the address is 1.2.3.4. So if you wanted to do DNS spoofing as a red team operation, these are the kind of prerequisites, the stuff you need set up. So first of all, you're going to need some sort of DNS spoofing software. So for instance, Cyberprobe, I've introduced to you, would take care of that. You also need some place to sit on the network to monitor requests. So for instance, one place to look might be on a switch. If there's a mirror span port, that's a good place to see what's going on the network. If there's a backbone tap, so put a network tap device like the Dns DAG card, I've used that to monitor 1 gig and 10 gig networks. Another technique, if your target enterprise has very low security in Wi-Fi, you could put a rogue Wi-Fi in place. If someone's being clumsy with credentials, you get the credentials, you've got a Linux router perhaps in your organization, good place to put some of this. And generally, I guess the best approach is always a friend in IT. At this point, I'm supposed to be doing a demo. Right, I'm sorry, this is the command line again, and there isn't cat means this time. So let's look at what things look like normally in my command. So I'm going to say, what is the address of example.org? And so remember this, the address of example.org, it begins with 93, and it's a real internet address. Let's go and have a look at DNSSEC. So I'm not going to go into detail what these records mean, but just remember, oh look, a whole bunch of records come out when we query them. This is the DNSSEC support for example.org. And the final thing, let's go and load the example.org website. There we go, and it looks like that. It says example domain. This domain is established to be used for illustrative purposes. Okay, so now I'm going to do a DNS spoofing scenario here, but it's this is going to be, for demo purposes, this is not typical of what you would do to red team spoof. So I'm running all of this inside a Linux VM, and what I'm going to be doing is injecting into the VM from the VM. It's really not a typical scenario, but it helps to show you the kind of things we can do with spoofing. So I've got this configuration file up here. I won't go into any detail, but that says if example.org turns up, I'm going to spoof the address 127.0.0.1, which will it's the address, loopback address. It means that any communications from this VM to example.org will loop back into the VM. And the other thing it will do is spoof a whole load of empty lists if anybody starts asking any queries for DNSSEC resources. So I'll just start that up. So see, this is live demo situation. DNS spoofing is non-deterministic, so we're rolling the dice here. So let's look up example.org, and it works. Phew. So the address that comes back. You wouldn't know what I had to sell to make that work. So example.org comes back 127.0.0.1. So the request went out, the response came back, but the spoofer was in there first. Let's also then see, let's roll of the dice again. We could do the roll of the drums here. This is the DS records. There we go. Thank you. So this come back and said no DS records. If I try and look up any of the DNSSEC records, they'll come back. There's none. We're just going to have to wing it without security. Trust whatever number you get back. And then the third thing I'll do is go back to this website. Now, 127.0.0.1, it's going to loop back and talk to the virtual machine. And on here, I've got a web server that's going to return a hello world page. So if I reload that, hopefully, yes. all 3 demo steps work. How pleased am I? That didn't work earlier. So that's the demo. So best practice in DNS security, a lot of the stuff you already know, or you will know if you've read the OWASP website. The application security provides a lot of security here. The TLS, HSTS certificate, but even though the red team can have a go at those, they're still valuable defenses. 2FA, everything you read on the OWASP site. I guess there's some things that are worth calling out specifically about DNS. The first, I guess, fighting rogue Wi-Fi access points. That is quite a significant threat in any enterprise. So if you're using kind of low-grade or personal-grade security, you want to be looking at the enterprise security, 8021X, those sort of standards, to make sure that the device knows it can trust the Wi-Fi, is not talking to a rogue Wi-Fi access point. And the second thing is your DNS servers. Remember we talked about earlier about how there was a packet race in this particular attack. Well, if your DNS servers are overloaded or might go down, it makes it easier for somebody who's spoofing to win that race. So DNS servers, making sure they're highly available and actually correctly set up for the load they'll have to handle. So the final thing to say is my cat's been DNS spoofing for 2 hours and made 180 quid, so it's not bad netting. Keep red teaming with Cyberprobe. Thank you.